Hey everyone, welcome back. I am so glad you are still with me. We finally reached a point where we can train a model and see machine learning at work. All we need to do is click on this Start Training button. But before you do, be aware that you need to pay attention to what is happening in the output window during the training process. I'm going to make my output window relatively large so that you can see what is happening. Now, let's click on this Start Training button to start the training process. In the output window, you will be able to infer which algorithms are being explored. Technically, what you'll see are the different trainers at work. Once the training is completed, you will see all the algorithms that were tried and the best fitting models that were created by the trainers. Model Builder uses terminology that I think is confusing. It will tell you which models were being explored, when in fact, it's not models being explored, it is algorithms that are being explored and models being created through the use of those algorithms. As long as you understand this, don't worry too much about the terminology. It might very well change in future. You might see the same algorithm name appear multiple times in the output window. This is because, in addition to trying different algorithms, Model Builder is also trying different hyperparameter configurations for those algorithms. In the training results summary just above the output window, you will see the best performing algorithm, not model, and the R-squared measure for that model. Model Builder also shows you the code behind files that were generated. The .cs file extension indicates that these are C# code files, which you will see were added to your project if you expand the Model Builder configuration node in the Solution Explorer. But our focus for now is on understanding machine learning, not on building apps or libraries that can employ machine learning. We'll therefore not be delving deeply into these code files in these lessons. You can also try retraining your models with a longer training time. You might see more algorithms being explored and possibly models with even higher R-squared metrics being created. Now that we have a trained model, we can actually use it to predict medical insurance costs or charges. Simply click on this Next Step button or the Evaluate tab on the left. Here, you will be able to see the details of your best model and the fields that you can populate in order to try out your model. All you need to do is enter some features into these fields, click on this Predict button over here, and you'll see the results over here. But before we do that, let's just cement a few foundational concepts. Remember that in this context, best model refers to the model with the highest R-squared metric. But also remember that this metric is a measure of how well the model fits the training data. It does not take into account how well the model will generalize to new data. And you would be forgiven for thinking that the model with the highest R-squared metric might be one that was overfitted to the training data. And you might be right. You will get to find out later. But to put your mind at ease in the meantime, ML.NET and Model Builder use a variety of mechanisms in the background to mitigate the potential for overfitting. Some of these techniques include cross-validation, which we chose as our validation strategy earlier, and early stopping, which I didn't go into previously. Cross-validation involves splitting the data into several subsets and training multiple models, Each model is trained on a different combination of these subsets and validated against the remaining data. This helps to ensure that the model generalizes better to unseen data. Then, you actually saw a form of early stopping in action when you chose to keep the default time to train earlier. Early stopping stops the training process before the model has had a chance to overfit the training data. And then there's something called regularization. ML.NET also uses regularization techniques to prevent overfitting. Regularization adds a penalty to the model for complexity. This encourages the model to learn simpler patterns in the data, which are less likely to cause overfitting. This is another complex topic that we can't delve into right now. But again, I'm just mentioning it to you to deepen your appreciation for everything happening behind the scenes that you don't have to worry about. Okay, let's get back to trying out our model. Model Builder automatically pre-filled these fields using data from our CSV file, specifically the second row in the dataset. Here, I've created a filtered subset of the CSV data in Excel. You can see that the second record in row 3 of this spreadsheet matches the data that Model Builder pre-populated for you in this screen. Let's use this default input data and try out our model. Technically, this is not new, unseen test data. This is training data that the model has been trained on. So in the background, Model Builder will be calling a predict method and passing previously seen features rather than new, unseen features to this method to predict the target for this training data. So let's click on predict and see what happens. Look at the value the model predicted versus the actual charges for this particular beneficiary. It is far off, way off. So you might be thinking, I must have done something wrong, or this model sucks. You are welcome to pause the video now and try to figure out why the prediction is so far off. The answer will not be obvious. The problem is that the smoker field was pre-populated with no, when it should have been pre-populated with false. If you go back to the Data tab and click on Advanced Data Options, you will see that the smoker feature is a Boolean, meaning that it can only be true or false. So let's go back to the Evaluate tab and change this value to false. Now let's click on Predict, and the answer is better. Not great, but better. This brings me to one of quite a few issues that I have with Model Builder at this point. There is not much here by way of field validation to help the user along. You should not have to wonder or guess why the model was so far off. Here's another example of where field validation is lacking. Let's enter the word something into the region field and click Predict. Model Builder will still predict a result, even though the input that you gave it is completely inappropriate. Another slightly annoying aspect of this user interface is that it only gives you predictions one record at a time. You have to re-enter features for a new record if you want to make a prediction for that record. You are welcome to try that on your own. But to spare you from watching me repeatedly entering new data to make predictions, I've already done this and populated my filtered subset with the Model Builder predictions. As you can see, the Model Builder's predictions come reasonably close to some of the actual targets, but is a bit off on other targets. Now, I'd like you to take a moment to think about why our model predicts some targets with more accuracy than others. To most of us, it will not be immediately obvious as to why this is. Perhaps you're thinking, let's retrain this model. Okay, let's do that. But how about this time we try to optimize our model using a different error metric? Let's go with the root mean squared error metric this time. Let's go back to Advanced Training Options. Select root mean squared error. Save. And click on Start Training. After the training is done, check out the root mean squared error value of the final model. Unlike the R-squared metric, it is not dimensionless. It will be the same unit as what the charges are in, and the lower this metric is for the final trained model, the better it is. But too low a value could imply that we have some overfitting going on. Let's see how well the model works this time round. Here is my updated spreadsheet that shows the Model Builder predictions using the new model. Slightly better results for some records, but slightly worse for others. Now what? Let's talk about what is going on here in the next lesson. I'll see you there.